Okay, so let us start. So I guess you guys must have received the solution of week one and week two assignment. And we were discussing one problem last week where a lot of conflicts was there. So with solution, I guess you might be able to visualize what was the thing there. So let me take that problem for you.
Hello, good evening, sir.
Good evening. So this was the problem, right? And I think number of turns of secondary winding has been changed in this, uh, which is different from the last year's problem. And initially, we were asked to find out the I2, right? So we want to find out I2. We have I1. I1 is given as 8 ampere. I2 is I3 is not given. Okay. So from the solution approach, if you go ahead, you can see they are doing MMF balance. So nothing but N1 I1, whatever primary supply is creating the MMF, that should be enough to cater both the load winding, which is N2 I2 plus N3 I3. Okay, and from this, if you can see, just I am bringing this N1 into denominator of both the side. Okay, I1 is equal to N2 I2 divided by N1 plus N3 I3 divided by N1. So both these currents can be called as, this is secondary current referred to the primary side, and this is tertiary current referred to the primary side. So I1 is nothing but the I2 dash plus I3. Now we are given with N1, N2, N3, I1, but we don't know what is I2 and I3. So that's what we have to find out. So to find out I2 and I3, right? We know the relationship between these two windings. V2 by V3 should be equal to N2 by N3. So that let me write. And similarly, V2, if you apply KVL in this loop, so V2 is nothing but I2 into 100, I2 R2, and V3 is equal to I3 R3. So now if you further equalize it, I2 into 100 divided by I3 into 50 is equal to N2 is 125, N3 is 50. So here you will get I2 as, sorry, you will get the ratio of I2 by I3, and that will be, let me cut out this. So 125 by 100, so 5 by 4. Now we find out the relation of I2 and I3. Now to find out I2 dash. Okay, so for I2 dash and I3 dash, so I2 dash is nothing but N2 I2 by N1, or let it put it this way. uh, I1 we will equalize I1 is equal to N2 I2 by N1 plus I3 dash is N3 I N1, and I3 is nothing but 4I2 into 5. So we have only two variables, I1 and I2. Even I1 is known, so let me plug in all those values. It is equal to 125 by 100 I2 plus 50 by 100 into 4 by 5 I2 plus 4 by 10 I2. Okay. So if you solve it, you will get I2 as 4.84 amps. Okay, I hope it is fine till now. Now the second part was to find out I3. So if we have found I2, we can find I3 as well. So from this expression, I3 is equal to 4 by 5 I2 to 4 by 5 into 4.84 amps. It will be 3.87 amps. Okay. Now the third part of the question was to uh, find out the RMS value of primary voltage, right? So V1 RMS. So I hope we have found I2 and I3. So what should be the approach to find V1 RMS? Any guess? Or you must have solved this problem, right, for the assignment. So
Using turn ratio, sorry, voltage per turn concept.
yeah, so we can compute V2 or V3. V2 was nothing but I2 R2, right? So I2 we have found out 4.84 into R2 was 100. So it is 484 volt V2. Now we want to find out V1. V1 by V2 is equal to N1 by N2, and it is 100 by 125. So V1 RMS would come out to be 387.87, right? You just need to plug in N1, N2, and V2. Now, how much power delivered by the source? This question has had issues in last session. So we computed from the load side, I2 square R2 plus I3 square R3. And we computed some load side and both were coming different. So that was the issue with the problem, I guess. In ideal transformer, whatever power is delivered to the load, that's the only power which will come from the source. So basically, there are no core loss and copper losses we are assuming here, right? So power, I2 square R2, and we will verify whether it is equal to Vs into I1 or not. Okay. So 4.84 square into R2 is 100. 3.87 square into 50. So how much it will come? Anyone has computed? Anyone?
Sir, 3091.405
Huh. How much? 3091 point?
watt.
405 watts. Okay. Are you sure this is the value?
Yes, sir.
Okay. And have you seen the solution?
Yes, sir.
So it is different, right? Isn't it?
How much was the primary current, sir? I want cross check from the
Okay.
power
So
delivery.
this value is coming from this expression or not?
Yes, sir,
This value.
exactly.
Okay. Let us compute with Vs into I1. Okay. So Vs we have computed, that is 387.87 into I1 RMS was 8 ampere. And if you compute it, it will again come less.
310.96.
310, 310,
2.
2.96.
Yeah. Watt.
Okay. So again, I think they have messed up with the data. That's why again we are getting different values.
Sir, I want to check value of the I1, sir.
I1 value is 8 ampere, right? I1 value is 8 ampere.
Approximately both are same, na, sir.
Approximately, but it is 10 watts, so we should not say approximately it is same, but anyway, the difference of 10 to
Or
11 watt. Uh,
10 point something is more only than.
that's fine, but that should not be the case if we are computing while considering the ideal transformer, right? Anyway, so you just computed from so whatever answer did you guys put? Please let me know. Did you guys put which one? This one, 310 or this one? And had your answer been corrected or it came in the wrong category.
Both
Let
are
me see.
different.
Let me see the range of the answer. Okay, so they have provided enough range. So by any means, if you compute, it will fall in the range. So no issue. You can compute via any method, right? So I hope your answers must be correct. Okay, now final part, uh, impedance seen by the source. Hmm.
48.48, sir.
48.48. What is the approach? I am more interested in
We
approach.
have put just value of the supply voltage and the value of the primary current, and then we just divide it to each other. Yeah.
Yeah. So yeah, this should be the approach, and I hope it is correct for all. Okay, so that's all about this problem. Any final doubt in this? Otherwise, we can move ahead.
Okay, sir, move ahead.
Okay, great.
Sir,
Yeah,
we are lagging, sir.
we are lagging in terms of.
Uh, in terms of there is no alignment between the uh, session which is going week which is going on the course and practice session which we are doing practice. Yeah, because in other words, sir, we are studying for the week 3 and week 4, and
Yeah,
we are in the practice for week 2. How is it
mhm.
possible, sir? So there is some slightly problem whenever we are doing the assignment problem. So
So,
this is my humbly request, sir. Please go through the week 3 questions.
week
Week
three
3,
assignment due date is over or not?
note, sir. Its last date is up to 16 August.
Yeah, so that's the point. Actually, we are not allowed to discuss current week's assignment. So that's the thing. Otherwise, we would have gone through only current week's assignment. So why we are discussing or everyone else, whoever might be taking these courses, so they are not allowed to discuss current week's assignment. Or that's the reason behind discussing previous week assignment. Unless your due date is over for that assignment, we cannot discuss that assignment.
Sir, I'm not talking about the assignment, sir. Just
Okay, you are talking about concepts.
concepts. Concepts
So
plus number of questions based on that concepts. Not exact assignment.
okay, so concepts you are not getting in lectures.
Yeah, getting, sir, but the in practice session we have to do the some practice on that concept, no, sir. That
Okay,
means we have to
so
face through the number of questions. on that concept in current going sessions.
Okay, okay. Let me see what I can do. Let me see if I have this previous years. Now just wait for a couple of minutes. Let me bring some.
Sir,
Yes, yes.
sir, can you share your email ID so that we can ask doubts whenever we have doubts based on other things also
Sure. I think I have already shared my email ID. But anyway, I will share my email ID. Uh,
in the chat box?
in the chat box I have already shared, but I will share again today. Okay, do not worry. I'm just finding out the last year's assignment of week 3. Okay, so we will discuss some problem based on efficiency. I hope this might be related to the current week's assignment. Am I correct?
Yes, sir.
Okay. So let us move ahead. We'll read the problem. I hope it is visible enough. Okay, so full load efficiency is given for this 450 kVA transformer. Okay, and maximum efficiency is also given at which condition it occurs. That value is not given, but condition is given. Now, power factor is given, which is assumed to be costly. Yeah, go ahead, please.
We can't see anything.
You can't see. Okay. Someone confirmed that he is able to see. Oh, now are you able to see?
Okay.
Okay. So read the question one more time. Okay. So as you might have read, this full load efficiency is given only 96%. Maximum efficiency at which load it is occurring, that is also given. Power factor is assumed to be 0.85 lagging at all loads. Now we have to estimate the copper loss. Okay. What should be the approach? You have to let me know. So first thing is output power at full load. How to compute? How much it should be? I hope you guys must have gone through the efficiency lectures and all.
Yes, sir. V2 into I2 into cos phi 2.
But here neither V2 is there nor I2 is there.
Sir,
So,
450 multiplied by 0.85.
yeah, correct. So it should be the output power at the rated load. And please tell me the value also of this calculation.
Sorry.
Sir, 382.5 kilowatt.
Great, thanks. So this is the output power at the rated load. Now we know the efficiency at this load, that is 0.6. And efficiency is nothing but the output power divided by input power. And output power we already know, that is 382.5. Input power we don't know. So we can write out input power is equal to output power plus losses. Okay. So if we further simplify it, it will be 382.5 divided by 382.5 plus losses. Okay. So how much losses will come out? Please compute it for me at full load.
$28.79 kilowatt.
28.79 kilowatt. Okay then. Apparently we have computed the losses. Now it these losses at full load came out from this only this statement, right? Only first statement. Now focus on the second statement. And what can we conclude from second statement? You have to let me know.
Yes, sir.
Huh.
The maximum efficiency occurred at 80% of the full load.
Yeah. And when does maximum efficiency occurs? That
Yes,
condition
sir.
you
X
should.
is equal to under root P core upon P loss. Sorry, P core upon P copper loss. Here
Okay.
X is equal to 0.8.
Yeah. So x is equal to. Am I right?
Yeah, exactly, sir.
So Pi is equal to x square PCU. Okay. So this is. Let us assume this as second and first was this Pi plus PCU. I can write it as Pi plus PCU.
Yes, sir.
Okay, so you have now two equations, two unknown. Can you compute Pi and PCU for me?
Sir, I got
Sorry.
hello.
Yeah, sorry. Please let me know.
Sir, I got 15 kilowatt total losses.
Sorry, I didn't get you. Did you tell me the value of Pi and PCU? Could you
Yes,
please
sir.
repeat whatever you said?
55 kilowatt.
Sorry, please repeat that. I think I have some network issue.
PCU is equal to
Yeah,
17.55 kilowatt.
yeah. It is full load copper loss, right?
Yeah, this is
Uh,
at rated. Yeah.
This is 11 point something, right? How much? 11 point.
Full load.
Sir, PCU is equal to 9.71 kilowatt.
Yeah, yeah. PCU is 9.71 kilowatt, and PI should be then
6.219.
6.1 kilowatt. Okay. Okay then. So we are done with the iron loss and copper loss. Okay. Now, since we have computed iron loss and copper loss, and we were asked find out the rated iron loss and rated copper loss. So this is the rated copper loss, and since iron loss does not vary with the load, so it will be constant, right? It will be same throughout the load.
Sir, but I got 17.55, sir.
Then you must have done some calculation mistake, I guess. You verify it once more and then
Yes, sir.
let me know.
PCU is equal to, sir,
Uh,
28.79 upon
upon
1. Yes, sir, 28.79 upon 1.64.
okay. I don't know how you are computing.
Sir, there is the first equation, sir. Pi
Uh,
plus PC is equal to
uh,
28.79 we get, okay?
okay.
And instead of Pi, we put the 0.64 PC
Uh-huh.
plus PC.
Yeah, yeah. This is so. Is this value is correct?
Uh,
I doubt this value might be wrong.
just
Yes,
me.
sir, it is wrong.
Yeah. How much is it?
Sir, 15.937.
Right. Now it is making
Yeah,
sense. So
15.937, yes, sir.
yeah.
Right.
So now the next part of the question is to find out the percentage efficiency at the half load. So how to compute?
Sir, by applying the formula of efficiency for degree of
Yeah.
loading.
So at half load, we have to apply again the same formula, right? So what should be the output power at half load?
Uh, Half of output power at full load.
Half of 450 kVA into
0.8.
so what? And it will be, please compute it while I am computing other things like losses. PI plus half load, so half to square into PCU at full load, right? So iron loss was 6.1 kilowatt. So compute both the value, this one and this one, and please let me know.
Sir, output power is equal to 191.25 kilowatt.
191.25 kilowatt. Okay, losses.
Sorry,
8.5
8.27.
8.27.
7, yeah. No, sir. 8.52.
8.52. Are you sure?
8.527.
5%.
Okay.
Okay. Okay, so I hope you guys must have felt that this solution is fine. And any doubt in this one?
No, sir.
Okay, then. We will go ahead with some other problem.
0.95%, sir.
Efficiency, right. Efficiency is
5.23%.
191.25 plus 191.25 plus 8.527. Okay. 95%, 95 point something it should be.
Yes,
But I hope you
95%.
got the idea.
Yeah.
So have you guys gone through the open circuit test and short circuit test?
Yes, sir.
Should I take a problem from there?
Yes, sir.
Okay. I hope you are able to see the question.
Yes, sir.
So 125 kVA, 2200 by 330 volt transformer with following test results. And here, these are the OC test parameters. These are the AC test parameters. We have to estimate all the parameters, okay, of the equivalent circuit. So, and along with equivalent winding resistance referred to the HV side. Okay. So AC side, AC test is performed on the LV side, short circuited, right? We cannot short the HV side for the short circuit test, and OC test we can perform with
Low
HV
voltage.
side, so low. So then, if we need to find out all the equivalent parameters, so from the short circuit test, let us compute resistance and all the parameters. So how much should be the resistance measured from the short circuit test? And how to compute that? So let us assume that I want to find out the resistance of the short
Sir,
circuit.
P is equal to I square RE1.
Yeah, correct. So it should be ESC divided by ISC square. It should be 1250 divided by 57 amperes square. And let me know the value of this.
Zero.
0 point.
No, sir. 1.0. Only one.
1.0. It is
Sir,
not possible.
0.3847. 0.3847.
Yeah.
Sorry, yeah.
So next thing, what should we compute from short circuit test? We have computed the resistance, right? Power divided by I square. And next thing we can compute the impedance, right? V by I. So 50 by 57. So, okay, while you compute this value, I will try to write the expression of
0.
reactance. How much?
0.87, sir.
0.8. X impedance value we can compute from Z square minus R square. How much will it be?
Zero 0.78, sir. Ohm.
Now we have computed all the parameters from SC test. Now we need to compute from OC test. So from the OC test, if we here a voltage is given, power is given, since it is done on the HV side kept open, right? So if HV side is kept open and 330 volt is from the LV side voltage from this side. So if you want to compute these parameters, right? These are the parameters should be computed from the OC test. So how to compute the resistance? This
Yes, sir.
voltage
LV side
330
on
upon.
LV side voltage upon I naught cos phi naught.
Okay, so
Sir, P is equal to V square by R0.
yeah, that is the expression which should refer.
LV upon.
So R0 we want to find out. V naught is given as, V naught square, that is 330 volt square, divided by P naught is 1875. So it should come out to be 58 ohm, right? So R naught we have computed. Now magnetizing impedance. How to compute? How to compute magnetizing impedance?
Sir, firstly we will calculate magnetizing current IM.
Sir,
Yeah. So go ahead. Yeah.
I have a thought, sir. To calculate R naught, copper loss, core loss resistance.
Go ahead.
First, I will. There is a given, sir, LV side voltage, okay, and I have also idea to calculate the current flowing through the resistor,
Okay.
which is magnetizing current into power factor cos phi naught. Then we simply divide. We simply take the ratio of low voltage side voltage upon I naught into cos phi naught.
Yeah, but cos phi naught is not given, right?
Yeah, we can calculate easily, sir, because wattmeter reading and the voltmeter and ammeter reading are also given in this question. So we know
Okay.
that wattmeter reading is equal to voltmeter, sorry, current coil reading and the pressure coil reading and the phase difference between both.
Are you telling this?
Yeah, exactly. Here from we
this
can
approach
calculate
also. Yeah.
phi naught.
Yeah. Cos phi naught you can compute, and then you can compute R by Z, right? So again, R to calculate R or Z, again you have to come to this approach, right? 330 by this V by I, basically 330 by this power. Power is equal to I square R. Power is equal to V naught square by R. So 1875 is equal to 330 square by R. So if you go through any approach, you can come out with the solution, but just make sure that what will take you to the shortest path. So that you should always think. But anyway, this is also the approach you can go. Yeah. Okay. So now tell me how to compute magnetizing impedance or magnetizing reactance.
In same way, sir.
What is the same way?
Sir,
Yeah.
now we know the current through resistance are not right,
Yeah.
which is 5.681 ampere.
5.681 ampere current through this.
Just we can do V divided by R naught.
Okay.
And we know the relation between these three current I naught equal to under root I A square plus I M square.
So you are saying that compute the current to IXM, right?
Yes, sir.
Yeah.
Sir,
So it
V1
should be 30 square minus 330 by 58. Right. So this we have already computed.
sir, I got 28.1111 ohm.
No. Please tell me this value first. Do not jump. What is the value of this current?
11.692 ampere.
11.692 amps. This is the value of magnetizing current. Okay, refer to LV
10.68.
side. Okay, so what should be the next step to compute magnetizing impedance?
Sir, V divided by 11.692. It will come 28.22 ohm.
330 divided by 11.69. So 22.
28.0.
Sir, 28.
28. 28 ohm, you got it. And yeah.
Sir, to find out the XM,
Uh-huh.
we have sorry, I have different approach, sir.
Wait, just a minute, okay. So we have
Sir,
computed
this
XM from
this
LV
answer
side.
is same.
Just wait for a minute. I will give you chance to speak. First, let us complete with this problem. We have computed XM and R0 from the LV side, right? But generally, OC test parameters, we refer to HV side. Am I right? So we need to further compute it towards HV side, both parameters. So what should be the value of XM with HV? 28 into 2200 divided by 330 square, isn't it?
Sir, 28 is
We have computed XM from LV side.
refer to the HV side, na, sir.
No, LV side we computed, right? 330 voltage which side? 330 voltage computed from which side? 330 is LV or HV?
LV, sir.
Then please let me know this value XM from HV side and R0 from HV side.
Sir, 2577.77.
2577.77. This R0, right?
No, sir, XM.
XM
SR
2577.
not, R not. SR R not XM, sir.
Sir, XM is equal to 1244 1244.44.
Yeah. So I think it is fine. Now what you were saying, just go ahead with that.
Sir, just I'm saying that I have a ammeter reading which is open circuit current. Okay. Sorry, no load current. We can say it open circuit current. Okay.
Okay.
And phasor diagram we can calculate Im is equal to I naught sin phi naught. And we
Yes.
have a voltmeter reading. Then we
Yes.
can easily calculate Xm1 is equal to voltmeter reading upon I meter reading I naught into sin phi naught.
Yeah.
From here we can calculate Xm, refer to the LV side.
Okay.
And then according to this question, we can just again we have to refer.
Yeah, that you can do. And you do that and you verify with the answer. If answer is coming same, then you can
Yes,
go
sir.
ahead with that.
Answer, my answer is coming that Xm is equal to 28.11.
Then it is fine. Indirectly, you are doing the same, right?
Yeah,
You are
yeah,
just
yes.
dealing with power factor, and
Yeah.
we are not dealing here with power factor. But anyway, you can go ahead with it anyway.
Yes, sir.
So I hope if there is any final question on this, go ahead, please.
Sir,
Yeah.
please, may you go through, sir, the relationship between the magnetizing component, sorry, magnetizing reactance and copper loss resistance refer to the primary and the secondary side.
Yeah. Are you able to see?
Yes, sir.
Sir, how can we calculate the efficiency from these two tests?
Okay. Efficiency, how to compute? Uh, See, short circuit test is generally done at the rated conditions, right? And that rated condition, if you find out power factors from the AC test, you will get the output power. Let me write it. Output power is equal to kVA into cos phi at rated. You can compute only at rated condition, right? Because any other load would be different because you don't know the power factor at any other load. So only rated we can talk about it here. Now losses you have already computed, right? So losses will be generally core loss and copper losses. So copper losses you can compute from the this resistance at short circuit test, but core loss computation would be a bit challenging here. So I think core loss parameters should be given, otherwise it would be difficult to compute core losses here. But if there must be some
Sir, in this
there must
question,
uh,
sorry, core loss is given in the form of open circuit wattmeter reading, no, sir.
yeah, correct. So core
And
losses is given
copper
here.
loss is already given in the short circuit wattmeter reading.
Yeah, you are correct.
Then
So both
where we can add.
both losses you add here, and both are at yeah. So OC test is anyway it is not dependent of the load, so it will be constant throughout 1875. And short circuit test you can compute with anything, and power factor you compute at this from short circuit test parameters. And I think you are done with all the parameters. You just have to do the calculation. Is it fine, Deepak?
Sir, cos
Yes,
phi
sir.
rate completed.
Sorry, go ahead.
Sorry, sir. The value of cos phi not rated.
Uh,
From which test we have to compute it?
no, cos phi not rated. You are saying this phi not. This is from the open circuit, but that will not come
Not
across
the
the rated condition. Yeah, so you have to find out the power factor from the SC test.
Because in AC test there is a full load test, sir.
Full load,
According to
yeah.
okay.
Okay, so this is the problem which I am posing. Actually, I have to leave early today because my health is not good
Sir,
today.
power factor is given, sir.
Sorry.
Sorry, go through previous question, sir.
Uh-huh.
Next question, sorry.
Uh-huh.
In this question,
Yeah.
power factor is already given.
So this question I did not discuss at all. So this is I am posing for you to solve it. Since I told I am leaving today early because I have fever for past couple of days, so I am not good. So that's why I am leaving today early. You could identify from my voice also. So just go through this problem, and I hope you will be good with all the AC test, OC test, and efficiency things, right?
Yes, sir.
So in next session we can discuss related to week 4 assignment and all. So this is the last problem which we can discuss from the week 3 assignment. So these 3 questions are good. Basically, these 3 questions are long questions. So in one question there was 2-3 parts. So uh, I think yeah, this is all related to this week. So we will meet next week. Is it fine?
Yes, sir.
Yeah. So
Sir,
sorry for
this
that.
problem is so simple.
Yeah, it's simple, right? So basically, you will get questions in assignment. They will be simple only. You won't get very tough questions from a single topic. In exam, actually, you have to